Life Comp0live is a European project entitled New Generation of Biocomposts based on olive fibres for industrial applications. It is coordinated by the National Plastic Technological Centre, Aldatech, and also has as partners the Olive Growing and Olive Oil Technological Centre, Sito Oliva, the University of Jaén, and the companies Ford, Caliplast, Plasturgia, and Matriceria Peña. The Life Comp0live project has been co-financed by the LIFE programme of the European Union, starting in July 2019 and having a planned duration of 4 years. The project arises as a demonstration of a sustainable and profitable recovery technology for the more than 7 million tonnes of pruning that are generated annually in Europe from pruning operations carried out in olive groves. This pruning is destroyed through burning in the field with the consequent problem of greenhouse gas emissions, or it is crushed and spread on the ground, which can favour the spread of pests. These practices also mean the loss of opportunity for the olive sector to incorporate schemes based on circular economy through the valorization of the generated byproducts. In contrast, there is a high demand for plastic materials of fossil origin in sectors such as the automotive and urban and domestic furniture. However, the regulation of these sectors advocates increasing the renewable and recyclable nature of these materials, something to which the Life Comp0live project contributes. To provide a comprehensive solution to these three problems, the Life Comp0live project focuses on the development of a new generation of composite materials from fibres from the pruning of the olive grove, which will be incorporated as reinforcement in component plastics for the automotive industry and the outdoor and home furniture, resulting in 3 new business models related to waste management in the olive grove value chain, increasing the added value of these byproducts and enhancing the use of waste to comply with current regulations and future. An important first step is to define the proper logistics for pruning. The Life Comp0live project works on this aspect and evaluates the volumes of pruning generated and their regional distribution, defining the scale of the transformation technology that optimizes the costs of collection and transport to the pre-treatment site. The pruning collected in the field, once transported, must be conditioned by means of a chemical pretreatment optimized by the University of Jaén to be able to be used as a reinforcement of the thermoplastic material. Prior to the treatment, the pruning is prepared and later crushed. By sieving, the fibre size of interest for the specific application is obtained. Next, the olive fibre fraction of interest is processed through a specific treatment to obtain chemically activated fibres that are more easily integrated into the plastic. Reagent concentration, treatment line and temperature are optimised in these small-scale assays. Next, the pre-treated fibre is mixed with the different polymetric matrices to obtain the composite materials. These polymers are polylactic acid PLA and recycled polypropylene RPP. As a result, the fibre and the polymer matrix are mixed with an extrusion pelletizing line to obtain pellets of a final composite material. The resulting biocomposite will be evaluated in terms of its mechanical, thermal and biodegradable properties for its validation. By using injection moulding equipment, the pellets obtained are transformed into samples that can be characterized. Biocomposites produced on a semi-industrial scale must meet, in terms of their characteristics, the requirements of the industrial partners that are Ford, Caliplast, Plasturgia and Matriceria Peña, which will be end users of these new materials. These companies will manufacture at least 3 prototypes containing the biocomposite developed in automobile components, urban furniture and domestic furniture. In short, the Life Comp0live project hopes to achieve the revaluation of at least 50% of the olive tree pruning, conferring a high added value to this byproduct. The creation of a green, ecological and sustainable compound with up to 40% olive fibre and based on recycled PLA or PP biopolymers. the reduction of plastic parts based on fossil fuels for automotive components and for the domestic and urban furniture sectors, reducing plastic consumption by at least between 10 and 40%. The development of 8 different biocomposites on a laboratory scale, 4 of which will be specifically applied following the requirements of each sector. The manufacture of 3 demonstrators of real and validated prototypes for the automotive, urban furniture and home industries.